There you go. The big thing I want you to watch for, though, in the book, here's the glitch is we really couldn't find the right book for this and so-called a college level course. Okay, so the book is really easier than we wanted it to be. So a couple of examples. One is I've handed you a conversion sheet, and I'd like you to be using this one. The tendency of the book is to find a simple conversion. If you're going from drops to milliliters, they'll just give you a conversion to go from there to there. But typically what you would do with drops is that's in actually the wonderful apothecary system, which you convert into drams. Then you can convert that to ounces. And then you go into milliliters or whatever you're needing, okay? So the book is almost like a Google approach where you just type in the number and the answer pops out. So the primary thing I want you to get out of this whole chunk is to be really good with dimensional analysis. Or sometimes you'll call it unit analysis. And when we say unit analysis or dimensional analysis, what it means is you're looking at the units. It's like, oh, that's millimeters, and that's kilometers, and you use those to know what to do. Okay? The units actually lead you to do the right multiplications or divisions you need to do. That's the idea of dimensional analysis. Okay? And this, for those of you who've taken chem or if chem's in your future, this is going to be really helpful with that. Okay? Even though here we'll be using, well, the first day is metric system, but getting really comfortable with this is going to help you a lot with chemistry and that kind of stuff. The other good thing about this is the book, again, will tend to give you, like, here's a little formula, you plug the numbers in, you're all happy. But what if you don't have the formula, right? And dimensional analysis actually allows you to just get to the answer without even having the formula, okay? So there probably won't be any note card on the test, the next test, because dimensional analysis allows you to get there without it, okay? So that's the little problem we have is the book takes quite a bit different approach than how we really want the class to go here, okay? So kind of use the book carefully don't take it too seriously, all right? And again, when we're done, I'd like to hear your opinions if it'd be better just to even get rid of it altogether, okay? So first thing, let's just do a review of the metric system. So typically when we think about doing conversions, there's 4 ways we do this. I can't quite read that. Actually, the thing we won't be doing is setting up ratios and proportions much at all. Okay, that's really a pretty standard tool for conversions, and it's good, and there's nothing against it. But I'd really like to push you into doing the dimensional analysis. Okay, and I'll do an example sometime just to compare. They're very similar in a certain sense. With the actual metric conversions, probably the easiest thing to do is just bumping the decimal around. So again, some of you may be already good with that, but I will go through it again. And there's one other option here, is sometimes you can simply take the prefix out, put in what the prefix means, and you're done with it. Sometimes it's even as easy as that, but it's not as universal. And if we have a little more time, I would maybe give you a short history on where the meter and kilogram came from, but let's come back to that. When we're adding and subtracting, the units have to be the same. It doesn't make any sense to say 2 kilograms plus 3 liters. What does that mean, right? But it does make sense to go 140 miles divided by 2 hours. That tells you 70 miles per hour, right? So multiplication and division, the units do not have to be the same at all. We use that all the time, actually. But addition and subtraction, units have to be the same. Okay? So let me run through the parts of this that I would like you to memorize and not. And actually, I think on the sheet, does it show up? It was highlighted in the color version. Is it like a little gray fuzziness maybe?
Over some of them, yeah.
Yeah. So those are the ones I would like you to memorize. So coming back to this, and on this chart up here, certainly mega and kilo you should memorize. That should be on your sheet. And milli and micro, you'll want to memorize those. So those are the big ones right up front, and then I'll show you a couple others that will be worth memorizing. So mega is times 10 to the 6, kilo times 10 to the 3, no prefix, and then we have down here is milli, lowercase m. Here, let me clarify that even more. Is that distinctive enough, maybe? So mega, capital M versus lowercase m. This is times 10 to the negative 3. And micro, which we tend to do MC, is times 10 to the negative 6. Little note on this. If you were in physics or engineering or most of those other disciplines, or chemistry, chemistry is a little gray, we use this. This is a cursive U here. It's a Greek letter. And let me see if I can do it even. It's a little more like that. It's Greek letter mu. And that's typically what we use for micro. The catch is, in the medical world, if you do a sloppy one of these, it looks like one of these. And suddenly you can either give a person 1,000 times more or less than they needed. So they're trying to ban this from the medical profession for that reason. Too many med errors, okay?
That one's not highlighted on the sheet if you want to
Oh,
know it.
yeah.
Yeah.
Yeah, you should know micro. I have to go back and change my sheet.
Yes, I think I do know that one.
Now we're going, I was about to get there. So that one is, we will want you to know that one. So I missed micro, huh? Bummer. Yeah, you definitely need to know micro. So the first thing to note here is, when it comes to memorizing these, so it's a pretty easy pattern, right? It's just the threes. 6, 3, 0, minus 3, minus 6. So that helps as far as the memorizing part goes. And then the reason I stammered on the centimeters, so once you see this is the main one, then we do like to stick in the little c for centi times 10 to the negative 2 as kind of an exception in there. Okay. We primarily use this for centimeters. It's close to an inch. So, and we also use it when you think about cc's, which, by the way, is another unit. Cubic centimeters is being banned in the medical profession, and they want you to use milliliters instead. It is the same. That's right. 1 cc equals 1 milliliter, but they don't want you to use that one. If you grab a syringe, it most likely will have both, but not necessarily. It may be only one or the other. Okay?
Is there a reason for that?
Again, it came down to some med errors. Yeah. It's a big deal. I know my wife is a nurse, and wow, you don't want that to happen. Not on your shift. Yeah. And the other one so this one would be used a lot in physics and other. The one that you guys end up encountering more is deca. Let's see here. The deca or the deciliter sometimes pops up. Nobody else uses it, but the medical profession will tend to use deca or deciliter a little bit. Okay? So that's the only reason I mentioned that one for you guys. They're headed that way. But otherwise, nobody else likes to use it. We'll just skip that one. So but if you can get these big 6 and then stick in this one little guy right here, you've got most of the metric conversions or the metric prefixes you need. Okay? So moving on a little bit so we can actually do some of these. So if you think about 0.56 milliliters, that would show up as, oh, perfect. You have a stick. You can imagine if you're looking at that syringe right there, 0.56 milliliters is going to show up right about there, right? And if you think about that, so now you can visualize how much is in there compared to a liter, right? Well, of course, this is actually probably, I don't know if it's a 1 or 2 liter bottle. But it would be pretty easy to imagine now, if I'm going to convert this into that, the answer that I write out, will it be a bigger number or a smaller number? right? It's going to be a lot smaller. And you can imagine, of course, because this is really small compared to that, right? So one of the biggest things you can do when you're doing the conversions is ask yourself, just try to visualize that, is, how does the size compare? So that'll help you a lot of times know if you're going to be writing a small number out or a big number out. Okay? So, again, one of the easiest ways to convert is if you can just replace, so there's our K right there, right? And it doesn't matter if it's K in front of the meters. Actually, let me back up. This was the list of prefixes, right? The main quantities we talked about would be M for meters, grams, so then of course this would be mass. All right, maybe I should have said this is length to be more consistent with that. And then we have liters, which would be volume, right? So those are the three main things we measure. And so all we're going to do is then stick prefixes in front of these. Okay? So with a problem like this, all you have to do is take out the K and put in what K is equal to, because we're just trying to go straight to meters. Same with this one. I have a lowercase. This is the prefix in front of the meters. So all we have to do is take that out, put in what it means. Where it doesn't work so well is like here, I'm going from this to this. So when you're going from one prefix to another, that approach doesn't work very well. We need to do something else, which is what we'll do next. So again, the way you would do the first couple, though, you would simply go 35 times 10 to the, and what's milli, the lowercase m? To the negative 3 meters, right? You've done the conversion. It's just simple as that. And the next one down, you would go 3.2 times 10 to the K's for 10 to the third meters. See, MCG, okay, so we can do that one as well. 27 times 10 to the negative 6 grams, right? So if you're simply going from, a prefix to taking the prefix away, it is just as easy as that, okay? You can just almost not think about that part. But as soon as you start going from one prefix to another, or where we don't have a prefix and we're trying to add it on, there's a better way of doing this, okay? So let's go and try that. So this is what you'll typically do, is you'll bump the decimal around, okay? So let's try to do some of these. And so if I were to come over here and write out, again, our big list, times 10 to the 6. And actually, you'll find that I struggle. I want to use micro all the time. I'm working at catching on to the MC part. Okay. So if I'm going from milli to no prefix, okay? So milli is right here, and I'm trying to go up to here, right? Do you see that? So the first thing I want you to recognize is we're moving 3 decimal places, right? You can see I'm going from here to here. If I were going from here to here, I'm moving how many decimal places? 3, 6, 9, 12, right? Or if I'm going from here down to here, I'd go 3, 6 decimal places. So I think if you look at the chart, it's really easy to tell how many decimal places to move. So now the next question is, which way do you move the decimal place? So here is my decimal place. And as I go from millis, from here, I'm going to here. Will my answer end up being a bigger number or a smaller number? So I've got these little measurements, right? It's kind of almost like that little syringe. And I'm moving over to a bigger one like that, big liter, 2 liter. We went smaller then, right? So I'm expecting this number to be smaller. So as you go up, you're going to move the decimal place to the left and make it smaller. if you find yourself going this direction, okay, then you're going to move the decimal place to the right, and you're going to make your answer bigger. Okay. So in this case, we know we're going to move 3 places, so 1, 2, 3, like that. Okay. So let's jump down to like 55. If I have 55 nanometers, and I'm trying to convert that into millimeters. So I'll start with, here's the milli, right? And I'm trying to go towards nano, which is, you have it on your chart there, right? Yeah. It's not one you probably need to memorize. We use it in electricity all the time, but not so much in the medical profession. So, but if I'm trying to go from here to here, so we're going to move it to the right, make it bigger. And how many places? 6, right? Okay. So here's my decimal place, and I would go 1, 2, 3, 4, 5, 6. Or you might choose to write that in scientific notation, right? Actually, how would you write that in scientific notation? 55 times 10 to the, how many decimal places did we move? 6. Yeah. Okay.
The decimal between the 5s? It would be like 5.5.
Oh, I'm glad. Good job. Yes. Okay. So this information is true. She's pointing out, though, there's a small flaw. What is that flaw? Yeah, to be really in scientific notation, we would need to take the decimal place that's here right now. We need to move it over. And so that means if I make this smaller, I'll make this bigger by 1. Okay. So it's the correct value, but yes. Good job. Thank you. Okay. Let's grab another one here. Let's see if we have 3.5 liters, and we're trying to make this into milliliters. So you see there is no prefix in front of my liters here, right? Okay, so that means I'm starting here, and I'm trying to just go down to here, right? So if I'm going down, it's going to get bigger, and I'll move it to the right. So 1, 2, 3. So we'd say then this is milliliters. Do I do any more of those? How's everybody? You know, I'm not exactly sure if this is like easy for you or good for you or hard. Can't tell out there. Sometimes you guys let me know, sometimes not. What's that?
I said Alan's not here.
Not to pick on the guy that's not here. But I don't know, do you do more of these, or I mean, are you kind of already comfortable with what we've been doing here? Okay, some of you do a pretty good job of nodding and smiling, and some of you a little more poker face out there. The next thing we could talk about would be doing the same thing by dimensional analysis. And so with these guys, it's a little bit optional because bumping the decimal works pretty well. But let's do just a couple of them. So when you're doing this assignment, I think most of the time you'll just be bumping the decimal around. But the very next few, the rest of the assignments will be lots of dimensional analysis. So let's try to repeat some of these guys here, but using this other approach. Okay, so this one here, and I would always start off just by writing it as a fraction when you're doing dimensional analysis. So we want to have, instead of millimeters, we want to have, well, we just want to have plain meters, right? That's our goal over here. When I do dimensional analysis, I like to write down over here on the right side what I want it to be, and then I'll start over here and see if I can make it and work it that way to make it happen, okay? So I want to get rid of that milli, right? So I'm going to write down below it, write millimeters. And up here I'd write meters. And then I would ask myself, how many millimeters are in 1 meter? If you look over here, there would be no prefix. So there'd be 1,000 of these and one of those. 3 zeros. Okay? Is everyone okay with the fact that there's 1,000 of these and one of these? Maybe, in fact, let's just state it explicitly. So there's, if you go down the chart, there's 1,000 of these and one of those. 1,000 of these and one of those. 1,000 of these. So if we don't have the centimeters out there, it's always going to be 1,000 into the next thing up. Okay? So again, we put this here because this was up here. We're actually doing division, or we're reducing the units out. So then this would cancel out that, right? So now we have the correct unit we wanted. So then we can actually then just go 35 divided by 1,000, and that'll be our answer. Okay? Let's see, if we were to do, let's do the 55 nanometers. So again, I'd recommend you starting putting things over 1. And I would like to eventually get this into millimeters. So I'm going to write nanometers down here. And can you tell me what would be the next group up from nanos? Got micros would be next. So I can say that there's 1,000 nanometers in 1 micrometer, right? Going from here to here. But then I don't want micrometers either, so I'm going to put micrometers here. And I can say that there's 1,000 micrometers in 1 millimeter, right? Going from there to there. And so now you can see that the nanometers would go away, the micrometers would go away, and we're left with just what we want. Okay? It's important to recognize that all of these guys are connected by multiplication. We're actually kind of like multiplying these fractions all together. Okay? So then this is going to be 55, because you can see we've got 1 and 1, so it's just 55. And in the bottom I have my denominator, 1 times 1,000 times 1,000, so I've got 1,000,000 down here. And you could do the division, or if you would like. Is that okay? Let's just do one more. Again, most of the stuff today you'll just be bumping the decimal around. And this will tend to use more as we go. Or in a problem like this. So in this problem, we're going to start off with 70 miles per 1 hour. Fine with that? And what we want it to be over here is feet per second. Like that? And let me give you some facts just to let you work with. Do you know how many feet there are in 1 mile? Anybody? You don't have to memorize this one. Oh, we're 5. Yeah, good job, guys. Yeah, 5,280 feet is equal to 1 mile. Okay. And let's see. We know that 1 hour is equal to 60 minutes, right? And we know that 1 minute is equal to 60 seconds. And that should be enough. Now, when I have these, I could also be writing them as fractions. I could say 1 mile over 5,280 feet, right? But there's nothing, and I could also flip it. I could write it as 5,280 feet in 1 mile. It's true too, right? Come on, we can do this. There we go. So what determines if we use this or this is simply what we need over here, okay? I don't want miles. How can I get rid of miles? Yeah, I can do, which one? This one or this one? The top one, because it's going to put the miles on the bottom, so I'll write this out as 5,280 feet in 1 mile. Okay, so good news is those guys are gone. How do I get rid of the hours? Yep, so I can write this as a fraction with hours on top. Good. So 1 hour over 60 minutes. So then this is gone, but I don't want minutes. So I'm going to put my 1 minute over 60 seconds, right? So then this will go away. So now on top I have, maybe you guys can tell me what I have on top. 1 times 1 times that. What did you tell me? I can get the bottom here.
369,600.
300, what? One more time?
369,600.
1,000 as in that, 600. Is that right?
Oh, 69, sorry.
So replace it there.
I don't know why I wasn't, I'm sorry. Thank you. Okay, so we've got that. Divided by, and 60 times 60 would just be that, right? And what happens when you divide that?
102 plus 6.
So this is really now 102 feet per second. Okay. So this is kind of the classic dimensional analysis that I would like you to become comfortable with. Okay. So a couple of things here.